Hello and welcome everybody to this presentation by Grandperspective on early warning of hazardous gas leaks. My name is René Braun. I'm founder and CEO of the Grandperspective, and I present to you today the Scanfeld early warning solution for hazardous gas leaks. The Grandperspective was founded in 2018 by a team of remote sensing experts. That's a revolutionary technology for the detection of gases from long distances. That is done optically, having the benefit of not bringing your sensor into a gas in order to detect it, which means you essentially have to know where the gas is, but using FTIR spectroscopy as a means of detecting and analyzing gas compositions from kilometers away. This technology is now routinely used since a couple of years by first responders and hazardous operational teams all over the world. And we bring this technology into the industry for a 24/7 constant monitoring of up to entire chemical parks. Today, the company counts more than 20 people, and you can visit our wonderful team on our website, www.grandperspective.de. Now, I present to you the technology and the application of the Scanfeld early warning solution on the example of monitoring the OCI nitrogen facility at the Camelot Chemical Park in the Netherlands. I present to you the why and how of the technology and the concept of the Scanfeld early warning solution and the application on the concrete example and how it looks like for the operators, and an outlook for future development in the summary. Basically, the Scanfeld solution has to do with two figures. The first one is the high amount of major gas releases that cannot be detected by common gas sensing technology due to the fact that if you have a local gas sensor, you have to bring it into the gas in order to determine the amount of gas in the air. And then you lack the information of the total amount, the sheer size of the gas cloud. For this reason, more than a third of major gas releases, and that's more than 300 kilograms of gas, go undetected by common gas sensors. In 2019, insurance companies reported in the EU and USA alone a insurance loss of $6 billion that have their root cause in undetected gas emissions. So the concept of the Scanfeld early warning solution is to monitor large areas up to entire chemical parks, that is production areas, storage facilities, systems of pipelines, unloading stations from the distance of roughly up to a kilometer per sensor unit, giving you the opportunity to monitor even large areas with a very small number of those sensor units. And that is done by a technology that is called remote sensing based on FTIR spectroscopy. And spectroscopy, that is something that is routinely used in the lab for chemical analysis. Why? Well, chemical analysis is the determination of the chemical composition, and FTIR spectroscopy has the benefit that it can distinguish up to several hundred chemical compounds, sometimes even in mixtures. This technology is now brought by the Grandperspective into the industry, developing a system for an automated 24/7 monitoring of the facility. Basically, this is answering 4 questions. Where is the gas? What is the chemical composition of the gas? How much is there, and since when is this event developing? This is a release experiment that we did at a refinery PCK close to Berlin, releasing a small amount of a technical gas and some ammonia into the air, and monitoring with a single sensor unit at a short distance of roughly 100 meters. You see here the sensor unit that is mounted on a tripod for demonstration unit reasons in order to show how the system can pick up the gas cloud and monitor the chemical composition and the distribution, the size of the gas cloud. So what you see here on this tripod is on the left a pan tilt unit that is constantly positioning and moving the sensor head. The sensor head is the FTIR spectrometer that is analyzing the chemical composition of the air. And once a gas in the library is identified, per scan the gas cloud, the distribution and the location of the gas is depicted. So for the control room operator, you have very intuitive information as an overlay to a video image where the gas cloud is located. And you have a very specific information of the chemical composition of the gas. Here you see the mixture of the technical gas, freon, and ammonia that is detected, and it is creating an alert that is sorted in a timeline, so you can go back and forth in time, see when this event started, how it developed over time, and you have very specific and precise information for the control room operator. So what you see here, or you've seen here, with this single sensor unit for demonstration units, is a platform solution that is freely scalable. So you have any number of sensor units that can be combined for the monitoring of an entire chemical park. So you see the example that I announced of this pilot installation for the OCI nitrogen at the Camelot Chemical Park in Geleen, in Holland. And we are monitoring the OMM, OCI OMM, that's a Urea Melamine compound that is situated in this park. And the Camelot Chemical Park is a really interesting park because it is one of the largest parks in Europe. It has more than 60 plants and 8,000 employees, 150 organizations. It's a very international park, having more than 100 nationalities of operators and people on board. And it's situated in a densely populated area. Around this park go several motorways. It's in the close vicinity of several large cities. Düsseldorf, for instance, on the German side. It's close to Maastricht on the Dutch side. And it has one other specialty, that is the Brightland Innovation Campus. That's a hub for startups, for entrepreneurs, for students, and that is situated in the Camelot Chemical Park in close vicinity to the OMM production site. So the goal for this pilot installation that we installed this summer at the OCI was rapid early warning, to instantly warn people, the operators on the ground in the control room, and of course people on the Brightland Innovation Campus, in case of a release of ammonia from the 4 stacks or within the production unit of the OMM. That is in roughly several hundred meters distance to the Brightland Innovation Campus. So speed is of the essence, and precisely monitoring and then tracking a moving gas cloud in order to prevent or to help in a situation when a gas cloud is propagating in the direction of the Brightland Innovation Campus. And that counts for all those chemical plants that are in close vicinity to any kinds of neighbors. That's true for most parks in Europe, where you have large cities or motorways or railway traffic in close vicinity. So in order to have a good overview, those sensor units are mounted on elevated positions, high towers, to have a good overview, to oversee the entire facility, the production site, storage sites, the system of pipelines. And you see here how the sensor units are mounted for the OCI. We deployed 2 sensor units there that are monitoring the entire production facility and have, at the same time, a very good overview into the Brightland Innovation Campus. So the idea is rapid detection and localization of the gas, an assessment of the situation in order to give the control room operator the specific information, where is how much of which gas, which situation he or she has at hand, and then track a propagating gas cloud in order to have a good situation overview as the situation unfolds. Those 2 sensor units are connected, in this case via a wireless connection, to a on-site server. So you have a dedicated hardware that is situated on-site and close vicinity to the control room, and provides the information for the control room operator in the user interface via the local network. The server does the data acquisition and analysis and provides an alert level that is based on the total amount of gas that is detected. And it gives a specific warning as in the means of video overlay of the scenery and the gas cloud, and pinpointing the location on a map. It also has a connection to the DCS, providing the alert as an automated value, and a very secure VPN remote support connection for our team of data analysts. You see here the 2 installation points of those sensor units mounted on 2 elevated points, 20 and 35 meters height, so you have a good overview of the entire production site or the entire 4 stacks and all the production units. And at the same time, on the left side and slightly out of the picture, the high profile area. This installation is 24/7 monitoring the entire production site and the campus, and it is scanning relevant areas sequentially on a predefined pattern, and has a turnaround time of currently less than 10 minutes. So every 10 minutes you have an entire overview. We positioned those sensor units, and this is what we are usually doing, in a very in-depth analysis of the on-site configuration, how the plant is situated, how the production sites, the relevant pipelines, and the storage and loading areas are situated, in order to have the best overview of all potential propagation scenarios. So for all potential scenarios, we have a good overview over the campus in order to early warn, in order for risk prevention in case of a accidental gas release, and then in mitigation terms to cover the propagation of the gas cloud. We started this pilot installation specifically with the goal of monitoring the OMM, the Urea and Melamine complex, and the Brightland Innovation Campus with those 2 sensor units, but have already pictured the technical planning for monitoring of the entire Camelot North side of up in total 1.6 square kilometers with a handful of sensor units. So the entire solution is designed to start off with a small installation, with a specific goal, and then being expandable, freely scalable. You can install any number of sensor units connecting to this solution. And here as a side note, at this point, the entire business model of the Grandperspective is being as flexible as the technical installation. We're not charging any hardware acquisition costs or any maintenance or repair costs. We're all covering this in a monthly fare that is expandable, freely scalable at all times. So what you see here is the user interface as the control room operator sees it. It's in its layout comparable to any video management tool. So you have the video image from each sensor unit of all those scan areas that are pre-selected areas of interest where a potentially a gas emission can occur. And those scan areas, you see those tiles here in this image, are sequentially scanned, and then the system is beginning at the start and continuously scanning all the site. And once a gas is detected and a chemical in the library is identified, you see here this example of the detection and localization of an ammonia emission. It is displayed over the video image, so it is intuitively the control room operator can understand where the gas emission is occurring, what the propagation direction is, and you can see the total amount in a false color display. And this amount value and the total size of the cloud, as well as parameters like the duration, for instance, all are scan area specific configuration levels for the alert generation. So the control room operator has in the timeline that is in the bottom of the image a timeline where you can go back and forth in time and then switch to a real-time modus. The alert level indicated by those colored triangles as low level, mid level, and high level alerts. And the red ones and the red part of the timeline is marking a high level incident where a significant amount of gas is released. You see here a small experiment, just a tiny amount of ammonia, water released into the air, and how this event is creating a predefined mid-level alert in order to demonstrate the profiling and the alarm generation. You can see here in the timeline that it is generating, in this case, mid-level alert that can be directly fed into the DCS. Remote support, that is the configuration, the remote maintenance, the remote analysis of the solution is done by a very secure VPN connection by our data analysts that are having a constant eye on the solution in order to provide best performance at all times, because you want to have very specific warning indicating only high-level alerts and not technical emissions. We are continuously monitoring and continuously deploying new software releases, new alert configurations, and all this is safely integrated into your data structure with the DCS connection. Together with the profiler, we provide the tracker module that is, in case of the detection of at least two sensor units, locating the gas cloud in 3D, the gas cloud composition and tracking a moving gas cloud and pinpointing that on a map. So you see here the better release of the tracker module that is picking up on an event that is happening within the facility monitored by those two sensor units, and it can be located, it's automatically located in the map, giving the location and the dimension of this ammonia cloud. So to sum it up, the Scanfeld early warning solution is designed to provide early warning of gas leaks because speed is of the essence. When you want to prevent a hazardous situation, you want a rapid situation assessment that gives the control room operator something that he can or she can clearly understand and intuitively grasp the situation. Having the precise information where, how much, which chemical is released. And in order to prevent risks and mitigate the effects of the incident, we provide not only the early warning, but tracking and monitoring an event as it develops. So with this conclusion, I want to thank you for your attention and motivate you to reach out via braun@grandperspective.de directly to me or via our website where you can find all information on the solution and the team on www.grandperspective.de and release you with the information that we provide pilot installations for all our customers, installations of a small scale with a limited duration and thus limited cost, no acquisition costs, in order to give you the opportunity to assess our technology on your site and in your case. Thank you for your attention.